Assalamu alaikum, welcome back to my channel. So we are going to prove that z is equal to z conjugate if and only if z is a real number. So to prove this, this is a two-sided proof. Like first we will take z is equal to z conjugate and prove at the end that z is a real number. Then conversely, we will prove that if z is a real number, then z is equal to z conjugate. As we are dealing with complex number, so let z is equal to x plus iota y. So this is equation number 1. Now assume z is equal to z conjugate. So we need to prove that z is a real number. Z is a real number. So as z is equal to z bar, and we know the z will use x plus iota y. So this implies that x plus iota y is equal to, and we know that when we take the conjugate on a complex number, so the sign with the imaginary number will be changed with the imaginary part, like x plus iota will change in x minus iota y. So this is the value of z, and this is the value of z conjugate. This implies that now shift the right side value on the left side, x plus iota y. This will change in minus x plus iota y is equal to 0. Now the real part will cancel with the real part because one is in minus form and one is in plus form. So this implies that 2 iota y is equal to 0. Now there are two numbers. One is 2 iota, which is imaginary number, and one is y, which is a real number. And the product of these both numbers are 0. As we know that 2 iota, which is an imaginary number, not is equal to 0. 2 iota, because of imaginary number, it's not is equal to 0. So if 2 iota is not equal to 0, this means y is equal to 0. So if we multiply 2 iota with y, it is equal to 0 because y is equal to 0. So if y is equal to 0, now put this y value into this equation number 1. So by putting this y value in equation number 1, this implies that z is equal to x plus iota into 0, which is equal to x plus 0, which is equal to x. Since z is equal to x and x is a real number, so this implies that z is a real number. And now we need to show conversely that if z is a real number, then z is equal to z conjugate. Now conversely, suppose z is a real number. Now we know that every real number is a complex number with 0 has iota, has imaginary number, like real numbers like 1, 2, 3 up to 7. These are all usually complex numbers. Like 1 with 1 we can write 0 as imaginary part, 0 iota. So suppose z is a real number, so this implies that z is equal to x plus 0 iota. So this is a real number. So if z is equal to x plus 0 iota, so this implies that this is equal to x, which is a real number. So this implies that what will be the z conjugate? So the z conjugate will change the sign of imaginary part. So this is equal to x minus 0 iota, which is also equal to x. So this implies that z is equal to z conjugate. Hence we prove that if z is a real number, then z is equal to z conjugate. Hence proved.